is Andres Rivero, and I work with composite morphing wings, specifically, like Ian said, with the FishBAC concept, which is a variable camber device. So before I begin with my presentation, I'm going to first introduce you to why we need variable camber in flying vehicles like fixed-wing aircraft. We wanted to also, the second point is to prove that we could design and manufacture a composite FishBAC. Also, that we can, of course, make it here in-house. And the final objective is to put this wing into a 2D wind tunnel test, and we can compare it with the traditional approach. So, variable camber, there's one main objective, and it's that we can change the amount of lift that a flying vehicle generates during flight. So, there's two ways I see this happening. The first one you can see on your left is what I call the nature's approach. It's basically a bird being able to adapt their wings configuration during flight, and they do it very efficiently. We also have what I call a traditional engineering approach, which is basically what we call a trailing edge plane flap. It's a hinge panel at the end of the wing, and we can actually up and down, like it depends on where the position is. They're called ailerons, rudder, and elevator, and they also can change the lift quite effectively. However, their shape change occurs in a very steep and discontinuous way, and there's a disadvantage to this. So if we can instead do it combine both approaches, and do it in a smooth and continuous way, but still localize our deflection at the trailing edge of the wing, we can get a better solution. And why is that? Because this approach of having smooth and continuous change generates less drag, and by having less drag, we reduce our fuel consumption, and we also have a noise reduction. So what you see here in the video is the FishBAC approach, and it consists mainly of, it's attached to a central rigid wing. You see on the left of my cab design. Then we have a central load-bearing member, a bending plate, which is made out of carbon fiber. We have a series of stringers that support the skin, and they keep the aerodynamic shape, and we have a pre-stressed elastomer skin that is keeping the airfoil geometry. So, there's three main objectives in our wind tunnel test. Like I said before, we wanted to prove that we could make a composite FishBAC device. Second, that we can compare it to a traditional trailing edge flap in a 2D wind tunnel test. And third, we wanted to make a modular wing so we can test multiple configurations in the future without having to redesign and manufacture a full wing. So the first step was to size the FishBAC, and I did this by using an analytical model that I developed during the first year of my PhD and loosely couple it with X-foil, and that way we could obtain the first stiffness requirements and also the actuation requirements. With this we chose the actuators and the main dimensions. Then I went to CAD and started designing it, and this is how the final design looks like. So after designing, of course, we have the manufacture. First thing we made was the carbon fiber spine, just standard pre-preg hand layup A552 IM7, autoclave bag, backing bag and autoclave gear, and then we have other features that are rigid that we 3D printed using UV cured 3D printed plastic. Also, we have silicone skin, like I said before, and we pre-stress to avoid buckling under compression, and we transfer the loads from our actuators that you see in the bottom right picture to the trailing edge of the wing using a series of hand-stitched tendons that just basically connect our pulleys to this morphing region. And the final step would be a wind tunnel test that is beginning today, actually, at Swansea University. We want to get both aerodynamic loads, but also get deformations inside the test section using digital image correlation. And future work, improve our structural model to allow to model transfer shear. Also have a fully 3D coupled, fully structured interaction routine. And my final step would be to optimize a 3D wing and further wind tunnel test it. And I would like to acknowledge the two funding agencies that contributed to this process. And also I have collaborators in University of Bristol and Swansea University as well that I would like to thank them. And while you see the time lapse I made for my wing build, does anyone have any questions?